Alrighty guys, let's go ahead and get started with this first problem. It says a 4 kilogram mass is attached to an ideal spring and oscillates horizontally with a period of 0.48 seconds and has an amplitude of 5.7 meters. First question says, what is the frequency of the spring mass system? So for number one, we're trying to figure out frequency, and we know that period is just equal to 1 over frequency. So if I take that equation down here, I can go ahead and rearrange it to solve for frequency. I'm going to multiply frequency over and then divide time over, and by time I mean period. So I get F is equal to 1 over T. Go ahead and plug my numbers in. I said above that my T is going to be 0.48. When I do that, I find out that my frequency should be 2.0833, and frequency is measured in hertz. Number two says, what is the spring constant of the spring? So in order to figure out the spring constant, we know the period. We're going to have to use our period equation up here. So I'm going to take that and bring it down here, where I have period of the spring, that's what that little s stands for, is equal to 2 pi times the square root of m over k. So if I need to get k by itself, I got to rearrange this equation a little bit. So I'm going to first divide by 2 pi to get the m and k on the same side and by itself. Now I have the square root of mk, so I need to square both sides of this equation. So doing so is going to make this square root disappear, and I'm going to be left with the period of a spring squared over 2 pi squared. It's important that the 2 pi is in parentheses there because both those things need to be squared, is equal to m over k. Again, the square root disappears when I square it. So if I'm solving for k here, I'm going to multiply k over and then divide this whole thing over. That's going to give me something that looks like this. K is equal to m divided by period squared times 2 pi squared. When I plug in my numbers, I know that my mass is 4 kilograms. I know that my T is 0.48, and I know pi is just a constant. I end up with a K value of 685.389 Newton meters. Next, I want to figure out what the mass's distance at a certain time is, and it tells me to make sure that my calculator is in radians. So to figure out distance, I need a distance equation, which is right here. So if I take this and write it down here, I get x is equal to a times cosine of 2 pi times f times t. In this case, it's little t, and little t just stands for time. So this right here is my little t. My f, I already solved for. It's right here. So f is this guy, and then a is right here as well. So I have all the variables. All I really do is just plug this into my calculator and make sure I'm in radians. After I do that, I find out that my a should be -2 meters. And it's -2, meaning that my spring in this case is compressed, not stretched. So if we keep moving along, we have how much energy is needed to stretch the mass this distance. Well, if we look at our equations, our energy equation is right here. So we have energy of a spring is equal to 1/2 kx squared. So if I'm trying to figure out the energy, I know what k is because I solved for it before. My k is just right here. I know what x is because I just solved for that. It's -2. And then I just have to plug everything in. So after plugging all my stuff into this equation, I find out that the energy needed should be 1,370.78. And remember, energy is measured in joules. All right, last question says, assume the mass is quadrupled. What is the new period? So if we take a look at the period equation, we know that period is equal to 2 pi, the square root of m over k. So if we quadruple this mass, that really means that we have the square root of 4m over k. Well, m and k are the same as before. All we're really doing is quadrupling it. So we really just have the square root of 4. The square root of 4 is just 2, meaning that our period is going to be 2 times as big as it was before.